Welcome to Spring LIB.
In this exercise, we're going to talk about circular motion, so let me briefly review it. What we need to know is that the centripetal acceleration that is associated with circular motion is equal to v squared over r, where v is the speed of the object and r is the radius of the circular trajectory. The centripetal acceleration exists even if the speed is constant, that is, the magnitude of the velocity doesn't change, and it arises due to the fact that the direction of the velocity changes along the circular motion. So let's apply this to the exercise. We have a car that makes a curve with a radius of 100 meters at a speed of 80 kilometers per hour. And our goal is to find what is the tilt angle theta, as shown here in the figure, that the car can make with the vertical, so that the only force that acts on a driver that is sitting on his seat is the normal force. Okay, so what we need to do is to draw a force diagram. Consider that this block here represents the driver, and we have the forces that act on the driver that are the normal force N and the gravitational force mg. Okay, now notice that the normal force makes an angle of theta with the vertical. So I'm going to decompose these forces into an x and y component, and I'm going to choose the y coordinate to be pointing upwards and the x coordinate to be pointing to the left. So in the y coordinate, we have n times the cosine of theta minus mg. This must be equal to 0 because we need that, according to the exercise, we need only the normal force to be acting on the driver, meaning that the gravitational force must be canceled out. If the gravitational force must be canceled out, then there must be no y component of the force, of the net force. In the x component, we have n times sine of theta, and this must be equal to the mass times the acceleration, which, as we saw, is the centripetal acceleration of v squared over r. Okay. So notice that what we want to find is the radius r, but we also don't know the value of the normal force n. So what I'm going to do is to take the first equation for the y coordinate and isolate n. So we obtain n is equal to mg divided by cosine of theta. So you can substitute the value of x into the into the x equation. So we have mg divided by cosine of theta times sine of theta is equal to mv squared over r. Okay. So our goal is to find theta. I may have said that the goal is to find r. I'm sorry for that. Actually, the goal is to find what is the value of theta. We already have the value of r. So notice that the tangent of theta is equal to v squared divided by rg. So theta is equal to the arc tangent of v squared divided by rg. So this is the arc tangent of v, which is 80 kilometers per hour. So I'm going to transform this here from kilometers per hour to meters per second. So we have to divide 80 kilometers per hour by 3.6 kilometers per hour by meter per second. And this is equal to 22.2 meters per second. So theta is the arctangent of 22.2 meters per second squared divided by r, that's 100 meters, times the g, that's 9.8 meters per second squared. So theta is equal to 26.7 degrees. And this must be the angle so that the only force that acts on the driver is the normal force, which concludes our exercise.